Okay, so there's another way to represent vectors algebraically. The one that we've shown you is the component form with the pointy brackets on it. But there's another way. And so if I consider this example with vector v being 5, 3, what I want you to see is that it really is the sum of a whole bunch of other vectors. In fact, any vector can be written in this as a sum of other vectors. The particular other vectors I'm going to talk about are the vectors I and j. I'm going to call them I and j. Vector I is going to be the vector 1, 0. So it's the vector starts at the origin and goes over 1 unit in the x direction. Okay. Vector j is the vector 0, 1. It's a vector starts at the origin and goes up 1 unit in the x direction. Okay. So vector I and vector j are just what we call unit vectors. They're 1 unit in length, and they go vector I goes horizontally 1 unit, and vector j goes vertically 1 unit. It's kind of our basic building block of vectors. Now this vector v is really the sum of 5 i's, right? You would take I plus I plus I plus I plus I, and 3 j's, j plus j plus j, and that would get you to the terminal point. So if you were to add 5 i's and 3 j's together, you would get vector v. Okay, so now we have sort of a combination, a way to combine i's and j's to get other vectors. So vector v then is a combination of 5 i's plus 3 j's. Okay, so I and j are what we call unit vectors. Some people will call them the basis of the coordinate system here, but basically they are unit vectors, and you add them together to get any vector. You can add multiples of them to get any vector. In this case, 5 i's, if you think about it, 5 times vector I, 1, 0, plus 3 times vector j, 0, 1, is going to equal the vector 5, 0 plus 0, 3, and when you add the components together, you just get the vector 5, 3, right? 5 plus 0 and 0 plus 3. And so that's 5, 3 is what we had before. Okay? And you can do this with any vector. Any vector you want, you just use the components as coefficients on the i's and the j's. So if I had another vector, we'll call it vector w, and let's say it's vector negative 6, 13.5. Okay, then if I want to write that in the ij form, I would write it as negative 6 i's plus 13.5j, right? Negative 6i plus 13.5j. And that gives us a new form, a new way to write these algebraically in terms of these two base unit vectors. Okay, I'm using the term unit vector. A unit vector is a vector of length 1 or magnitude 1. Kind of an interesting thing is you can have a unit vector in any direction. I could create a unit vector in the direction of vector v simply by taking vector v and dividing by its own magnitude. It's kind of an interesting concept. If I were to think of this as vector u, I'll use u for unit vector. If u is a unit vector in the direction of v, then I would take vector u to be 1 over the magnitude of v times, times vector v. Okay. In other words, I'd be dividing each of the components by its magnitude, right? 1 over the magnitude is a constant. The vector is a constant times a vector, so you're basically taking a length and scaling it down by 1 over the magnitude of v. The magnitude of this vector is the square root of the sum of the squares. That's 25 plus 9, which is the square root of 34. So I'd have as my unit vector 5 over root 34, comma, 3 over root 34. And of course you could rationalize those denominators if needed. I'm not going to go through all that work right now. But this vector then has a magnitude of 1 and is in the direction of my original vector v. Okay, so two interesting points here. One is to be able to construct any vector or build any vector as a linear combination of i's and j's, and also to be able to construct a unit vector off of any vector in the direction of any other vector that's known.